All right, peeps, here we go. So, climate change debate, and it is a debate. All right, here we go on this one. Right there. Um, Climate change is a debate. Why? Because it's not fact, it's theory. It can go either way. It does look like the climate is changing. All right, that is not debatable. What is debatable is kind of the reason why it is changing. So, um, what isn't debatable is there is a greenhouse effect. All right, some people are like, oh, it doesn't really contribute too hard to the climate change. Others, like myself, are like, no, the greenhouse gas is definitely a reason why we're warming up. Another one, greenhouse gases are increasing because of human activities. Non-debatable. Look, you take oil out of the earth, you turn it to gasoline, you burn it in a gasoline engine, and you put it up in the atmosphere. Guess what? That's got an effect. Average global temperature has risen. Non-debatable. Last 100 years, temperature's gone up overall when you look at the average. Um, Opponents do bring up about climate change, the Earth's wobble or tilt. You might notice that from sophomore or freshman year when you were in my class, where we talked about the Milankovitch cycles, sunspot activity. Like basically, the sun is not consistent. It's not just like putting out like average heat. It has these things like solar flares, like pew, like that, like almost like a burp or a belch. And then when that solar flare happens, it puts out more energy. So, increases in temperature, greenhouse gases. Like the opponents bring up increased temps, increased greenhouse gases. They're like, oh, the two don't relate. You know. What I want you to do is go on to page 328. What were human produced sources of carbon dioxide, methane, nitrous oxide, CFCs, and ozone? So, yeah, I mentioned those in the part one of this video, most of them. Some of them you might have to look up, but I want you to look up those. Climate change is more than global warming. I've said it before, I'll say it again. Um, global, global warming is just part of climate change. There's other things involved with it. Includes global warming, precipitation, which is rain or snow, severe weather events, hurricanes, tsunamis, earthquakes, stuff like that, sea level rises, and ice sheet reduction. So, ice sheet reduction isn't just glaciers, it's also like polar ice caps, Greenland, stuff like that. So, five ways climate changes with greenhouse gases. I'm going to underline that right there. There's a direct relationship. More solar radiation coming in, consistent change. So they're like, look, with more sunlight coming in, the temperature just consistently goes up. Another one is more of a buffering action where they're like, yeah, more solar radiation's coming in, but it's you got an up and down, sort of it's the average that shows change. Another one is slow change initially, but then accelerates up. So another one is like, it's no change, no change, and then it just ramps up real suddenly. So, which brings us to tipping point. Uh, Tipping point for me, there's like no change until it reaches a point, then it drastically changes. Think of it as like that quiet kid in the classroom is like, okay, and he's just getting made fun of. He's just like, okay, handle it, handle it, handle it. Nothing changes, nothing changes. Then one day, just Rah! All right, that's like a tipping point. So, no change, but when the change happens, it's drastic. Which brings us to the last one. After the tipping point, um, it can get stuck in a new equilibrium. So, like, look, just like that student in the classroom, like, good student, good student, nothing happens, namaste. Blow up, now he's in trouble. Like, now for the classes going forward, I know that's kind of his, I have to watch out for him. So that's the new tipping point. I didn't have to watch out for him beforehand, but after that tipping point, I kind of have to. So, five ways so yeah, with that, IPCC, International Panel of Climate Change. These people are like hundreds of scientists globally that are put around. The consensus is 95 to 100% sure that humans have impacted the global warming. One of the things is like you'll have people bring up, they're like, scientists aren't positive or aren't sure about like climate change and global warming. you have to realize their job as scientists is, the word never. They don't really do absolutes. They're not going to be like 100% sure that the Celtics are going to win the series or 100% sure that climate change is happening. They're just going to tell you most likely, not likely, highly unlikely. Um, so they don't really speak in absolutes like that about anything, much less climate change. Um, impacts of climate change: ocean, sea level rises. This means warmer oceans, water expands. One of the things you should know, like water into an ice cube tray, it gets condensed, and that means it's more dense. Now, as something heats up, it expands, it becomes less dense. So, not only is it sea level rising, but it's like warmer oceans, and then so that contributes to even more of the ice melting, and also fish migration patterns, and also water expanding is going to make the sea level rise that much more. Um, the ocean does absorb carbon dioxide. The only problem is when it does that, it becomes very acidic, and this is a big time problem for coral reefs because coral reefs are they're great habitats for fish to live in, but they need a certain seawater temperature. They need a certain acidity. And if it becomes too acidic, man, it's like a bad relationship. They just can't live in it. So they die. And then fishy's got no homes, and that affects our fisheries and whatnot. Also, fish don't do very well in acidic waters as well. So, yeah. Uh, so warm is also the warmer the ocean, the less carbon dioxide it absorbs. So as the more and more of our oceans warm up, it's going to absorb less carbon dioxide. So that means more carbon dioxide into our um, environment. You can think of that as positive and negative feedback loops. So our oceans, how they can only absorb so much carbon dioxide, that is a negative feedback loop. That means they get to a certain point and no mas. And then the positive feedback loop is now it just consistently gets dumped more and more and more and more into the atmosphere for that carbon dioxide. Ice caps, melting, increased sea levels. So obviously, this isn't glaciers, by the way. This is just straight up ice caps, like the North Pole, Greenland, stuff like that. Um, Melting ice caps increases the sea level, messes up the ocean currents. Why? Because like fresh water comes storming on into the oceans. It's warmer. The currents don't move like they used to. Um, and it messes up climates for certain area. I brought up earlier in part one, we talked about Scandinavia and England. Well, if that current from the Caribbean gets messed up going to Scandinavia in England, there's no warm water going up to Scandinavia in England. It's actually going to get colder up there, you know, because of it. Conversely, too, if the current in the Pacific gets messed up and none of that like water over by Hawaii, that nice warm water, that nice warm water, if it doesn't go up towards Japan, if that water doesn't come down from the Arctic and hit San Francisco like it usually does, San Francisco and your wine growing region are going to be a lot warmer because of that, without that cold ocean water coming in, and it'll be warmer, harder to grow grapes for wine, harder to live. It's warmer there. So, yep. Let's see. One thing about melting of the polar ice caps, it's going to open up this trade route way up in the North Sea, the Arctic Passage. It's going to make transit of ships a lot more easy between countries. And they're kind of fighting over those traffic lanes in a way. So it's opening up ocean trade routes. It also opens up undersea mining and exploring for fossil fuels like coal, oil, natural gas under the ocean. So just with that sea ice melting. So different things, peeps. So, yep, that's what we got so far.